Let's review the properties of acids and bases and rules to name acids and bases. So one of the most simple definition of an acid, the Arrhenius definition of an acid, is that anything that produces hydrogen ion, H plus in solution, whereas a base is anything that produces hydroxide, OH ions in solution. And the properties of acids and bases are covered here. Remember, both acid and bases conduct electricity. However, acids convert blue limits to red, whereas bases change red limits to blue. Acids have a pH of less than 7, whereas bases have a pH of greater than 7. Acids have a sour taste, bases have a bitter taste. And here is the opposite points. Acids react with bases to neutralize them, whereas bases react with acids to neutralize them. Here's a point that's often overlooked. Acids react with metals to produce hydrogen gas. So we could say acid, hydrochloric acid, for example, reacts with zinc, which is a metal, to give you zinc chloride and hydrogen gas. And we can balance the equation by putting a 2 in front of the hydrochloric acid. You should also note that there is no similar property for bases. There's no guarantee of a specific product when you react a base with anything. And here is the pH scale. In your previous studies, you may remember that acidic compounds have pHs of less than 7. So the 7 here is our neutral point. So something like our hydrochloric acid, something like vinegar, CH3COOH, orange juice, lemon juice, they're all acidic. On the other hand, alkaline or basic compounds have a pH of greater than 7, pH of greater than 7, so there could be soap, could be ammonia, could be potassium hydroxide, you sometimes use in cooking. Those all are basic or alkaline solutions. So now let's go over rules to naming an acid. First, we have to name the acidic compound as though it was an ionic compound. Then we're going to take that ionic name and then convert it using our rules to convert it into acidic compound names. It's best to go over the rules using some examples. So here, our first example here is hydrogen chloride, HCl. We're going to name it as the ionic compound, hydrogen chloride, and then using our first rule here, where if it ends in an "ide", we're going to change the name into hydro something ic acid. So hydrogen chloride here becomes hydrochloric acid. Our next example is HNO3. Naming it as an ionic compound, we get hydrogen nitrate, and it ends in 8. And our rules here says that if it ends in 8, we convert it into something ic acid. So what does it become? It becomes nitric acid. Next, we have H2S. Dihydrogen sulfide would be the name if we're to name it in sort of the ionic model. So then we have ending in "ide", so we go back to our first rule here, "ide", so that it becomes hydrosulfuric acid. And then lastly, we have H2SO3, SO3, which if we're to name it as though it's an ionic compound, it becomes hydrogen sulfite. SO3 is sulfite, remember? And here, it ends with ite, ITE. So our rule says that our acidic name is something us acid. So it's now sulfurous acid. Sometimes you can encounter compounds what we call oxyanions. And what that is simply a polyatomic ion that has an oxygen in it. So the example here is we're going to look at phosphate, PO4 3 negative, but we can also look at nitrate. We can also look at as sulfate, or sometimes we can look at chlorate. But let's focus on phosphate. So the most common form of the oxyanion is often ends in 8. So phosphate, nitrate, sulfate, chlorate. if that compound in question has one more oxygen than the usual form, then we add the prefix of per in front of it. So PO4 is our usual form again, right, up here. PO4 is our usual form. So PO5, right, one additional hydrogen, we're going to call it per phosphate. The next rule is if we go down one oxygen atom, one fewer oxygen atom, we change its ending to "ite." So in this case, PO4 was our most common form. PO3, having one less oxygen, we call it phosphite. And then lastly, if we have two fewer oxygen atoms than its usual form, we call it hypo something ite. So in this case, we have PO2. Now, this is two fewer oxygens than PO4, so we call PO4 hypophosphite. And all of these rules also apply to nitrate, sulfate, and chlorate. We can apply the rules for naming oxyanions into oxyacids. So here, HClO3, the name of it, if it was an ionic compound, is hydrogen chlorate. Now, if you remember from our rules a couple of slides ago, 8, the conversion to 8 is ic. So hydrogen chlorate becomes chloric acid. Let's look at H2SO2. SO2 has two fewer oxygen than the usual form, sulfate. So if we were to name it as an ionic compound, we'd call it hydrogen hyposulfite. Now, if you remember the rules for naming acid, ite becomes us. And we have to keep the hypo prefix as well. So the name for H2SO2 is hypo, sulfurous acid. And lastly, let's look at H2CrO5. If you look in the polyatomic chart within your periodic table, you won't find CrO5, you will find though CrO4. And CrO4 is chromate, and CrO5, having one more oxygen than CrO4, is perchromate. And if you again remember from our acid naming rules, 8 changes into ic, and we still need to keep the prefix per, so H2CrO5 is perchloric acid. And as we mentioned, sometimes you won't find the particular oxyanion that you're looking for in your table of polyatomic compounds, but if we look at the ones for chlorate, we'll see the trend is present throughout. So you can apply those rules from chlorate into other polyatomic compounds as well. Okay, so let's try some practice questions. We have 4 formulas here. Can you please write the name of those 4 acid formulas? And on the right, we have 4 names of acids. Please convert those into formulas. So pause the video here, and in a few seconds, we'll come back and finish off the video. Okay, let's look at the answers. So H2CO3, if we're to name it as an ionic compound, is hydrogen carbonate. So 8 changes to ic. So this is carbonic acid. Next, we have H3PO5. If we're to name it as a ionic compound, it becomes hydrogen perphosphate. So 8, right, becomes ic. So this is perphosphoric acid. Okay, HI, the ionic name would be hydrogen iodide. So then hydrogen, something ide, becomes hydroic acid. So this becomes hydroiodic acid. And lastly, H2BO2. Now, you won't find BO2 in your periodic table. You will though find BO3. And BO3 is borate. So BO2, having one less oxygen, would be borite. So the ionic name would be hydrogen borite. And then if we're to change that into acid naming, ite becomes us. So then this becomes borous acid. Let's look at the opposite task. We're given the name of a formula and we determine the formula of the acid. So the first one here is hydronitric acid. So hydroic implies that the name of the compound is hydrogen something ide. And what is that something? It's going to be nitrogen. So N, hydrogen nitride. So the formula for that will be HN. However, if we look closely, we notice that the charges are not balanced because the anionic charge of nitride is 3-. So we actually need 3 hydrogens, which are each singly positive, to balance off the nitrogen. So the correct formula for hydronitric acid is H3N aqueous. Next we have sulfuric acid. So ic implies that it came from 8. So the proper ionic compound name for it would be hydrogen sulfate. And luckily, the naming is relatively simple, SO4 with an H in front. And if we check the charge on SO4, we notice that it's 2 negative. Therefore, that means we need 2 hydrogens to properly balance off sulfate. So the formula for sulfuric acid is H2SO4. Next, we have periodic acid. Again, it has a suffix of "ic", but a prefix of "per", so that means it came from periodate. And the chemical formula for periodate is IO4. And IO4, if you check on periodic table, is 1-. That means we need 1 hydrogen to balance off the charge. So the formula for periodic acid is HIO4. And lastly, we have hypobromous acid. Right? Us tells us that it came from bromite. And don't forget the prefix of hypo. So that means this came from hypobromite. And if we look on our periodic table, we find that the bromate is BO3. So then hypobromite means there are 2 fewer oxygens. So this is BO. And if we were to check our periodic table, the charge on BO is 1 negative. So we have 1 hydrogen to balance it off. So hypobromous acid is HBO. So hopefully you understand those examples. I strongly encourage you to try some examples on your own.